We've already seen how arrays and records work. However, so far we use them only as immutable data structures, meaning we never modified them. In this section, we will learn that we can also modify these data structures in place. Let's get started with arrays. We created an array of 3 elements. Arrays are fixed size at creation time, meaning when we define an array, we cannot change its size later. So this array will always have 3 elements. We can extract a specific element of an array using an index. In our example, we are accessing the second element of our array, which is solo. And arrays are also mutable, so each element of an array can be modified in place. And when this happens, the old modified value will be lost. Let's take a look. We used an index to access the third element of our array. And using the equal sign, we modified it. We changed the pilot string element to the smuggler string element. So we didn't create a copy of the array. The array is still the same as before. We just modified it in place. As you can see, the modification operation has a type of unit because it's a side effect. Being able to modify the content of an array in place enables us to write imperative code. Let's take a look at an example. We defined the rotate function, which will move the first element of the array to the last position in the array using the for loop. As you can see, this function returns unit, which means it returns nothing because it's performing a side effect. Let's call this function. We defined an array called Han. Then we pass this array to our rotate function. Inside the function's body, we first stored the length of an array here and its first element here. Then we used the for loop to loop through our array and to modify each element. Finally, we added the original first element at the end of our array. Then we checked the content of the modified array, and as you can see, the first element was moved to the last position in the array. We moved the first element, Han, to the last position. Let's pass this modified array to our function again. Once again, array's first element, this time solo, was moved to the last position. Let's now talk about records. When creating a record, we need to declare its type first. We declared the record type person, which contains fields of first name, last name, and occupation, and all of them are strings. Since we declared the type of our record, we can now create one. As you can see, our newly created look record has the same fields as our person record. When we run this code, you can see that the compiler is telling us that our look record has a type of person. Let's try to modify this record. We used the dot notation to access the occupation field of our record, and using the equal sign we tried to modify it. However, we got an error telling us that this record field isn't mutable. So, by default, this whole record is immutable. We cannot change it in place. In the case of an array, all its elements are mutable by default. In the case of a record, on the other hand, we need to decide in advance which part of this data structure can be modified in place. Let's take a look at how to make specific fields of our record mutable. We tackled our record a little bit. We added the mutable keyword in front of the occupation field in the person type declaration. By doing that, we declared that this field is mutable and can be modified in place. As you can see, the compiler's error is gone and modification of the occupation field works. We used the dot notation to access this field, and using the equal sign, we modified it. So we didn't create a copy of this record. The record is still the same as before, we just modified it in place. We changed the value of the occupation field from the Jedi string to the farmer string. As you can see, this modification operation has a type of unit because it's a side effect.